Hi guys, I'm sorry that we have taken so long to cover content, but we are very much available for any questions. Now let's take a few minutes to watch this video.
A closed system, calcium carbonate will decompose to form calcium oxide and carbon dioxide. As the amounts of calcium oxide and carbon dioxide increase, a reverse reaction occurs and calcium carbonate is resynthesized. When the decomposition rate of calcium carbonate equals the synthesizing rate of calcium oxide and carbon dioxide, the system is said to be at dynamic equilibrium.
Hi ladies and gentlemen, would like to welcome you to Science Explained with Mr. K, and today I am going to cover chemical equilibrium, and I hope that you're going to enjoy and you're going to understand everything at the end of the lesson. What is chemical equilibrium? Right, by now you would have covered rates of reaction, and by now you understand that if we have a single arrow, the single arrow would mean that the reaction has to reach completion. Okay, now when the moment you talk about chemical equilibrium, you understand that now we are going to talk about the double arrow. Now the moment you see an equation with a double arrow, it's an indication that the reaction is reversible. Now because this reaction is reversible, it means we can reach a stage where it seems as if nothing is happening, especially if you're doing an experiment. It's when you observe that type of an experiment, it would seem as if nothing is happening. Why? Because the reactants are going to synthesize to form products. The products are going to decompose to form reactants. But now it's going to get to a stage where both these processes are happening at the same time. And as soon as they happen at the same time, we reach a state that we say is an equilibrium state. That is why now we're talking about chemical equilibrium. Now, what is chemical equilibrium? According to what we understand now, if I'm going to reach an equilibrium state, it would mean that the rate of the forward reaction, which is where the reactants they synthesize to form the products, is equal to the rate of the reverse reaction, where the products are going to decompose to form reactants. So now I hope that the issue of equilibrium is understood. But of course, it doesn't just end there. We need to understand that the reaction will still continue. It is just that to our eyes, when we are observing, it seems as if nothing is happening, but yet it's continuous. Okay, so this reaction is continuous simply because it has reached equilibrium. So when we get to that stage where the reaction is continuous, we say that it has reached dynamic equilibrium. The moment you talk about dynamic, it means that we have reached equilibrium, but the reaction still continues. Okay, of course it doesn't just end there. Then we need to look at other things that can affect the position of equilibrium. Okay, because in any situation we do understand that we can have external factors, but for equilibrium to be established, the rate of the forward must be equal to the rate of the reverse, and at the same time it must be in a closed system, not an open system, a closed system, because in a closed system we don't allow any external factors to affect the experiment. Okay, we are merely controlling the experiment. So that is why external factors will not at this stage be allowed in a closed system. Okay, now what are these external factors? We are going to look at temperature, we are going to look at concentration, we are going to look at pressure, and we are also going to talk about a catalyst. Okay, now with regards to a catalyst, let me start with a catalyst. A catalyst does not necessarily affect the position of equilibrium, because if you go back and you look at the function of a catalyst, it speeds up the forward, but now because this is a reversible reaction, it's going to speed up the forward and it will also speed up the reverse reaction. Right, as far as the temperature is concerned, I want you to think about the rate of reaction. We were talking about kinetic energy between particles. Of course, the moment you talk about temperature, you need to keep in mind that at the same time you're talking about the kinetic energy of the particles, because this time when you increase temperature, the particles are able to move freely, they're able to collide faster, and hence we have more effective collisions per unit time. And when you decrease temperature, obviously particles are at a fixed position, they are unable to move freely, hence you will have less number of collisions. Okay, so temperature does affect the position of equilibrium. Say for instance an equilibrium is reached at a temperature of 20 degrees. Right, the moment you increase that temperature to 30, that means you are increasing it by 10. So the system needs to find its way to have a balance some sort of way. Now I want you to think of this. Say you take in a lot of sugar in your body, right? After some time you're going to feel weird. You are going to feel weird simply because your body is not used to that amount of sugar. So what happens is, because there's a lot of sugar in your body, what your body would want to reach equilibrium, and the only way your body can reach equilibrium is when you vomit, because I'm pretty sure all of us can agree that when it comes after vomiting, we actually feel better. We actually feel very much better, simply because your body has reached equilibrium. Okay, so going back to temperature, when you increase temperature, you are disturbing the position of equilibrium. So chances are at this stage we can produce more products or we can produce more reactants. So the system needs to find a way to find balance again. So hence temperature becomes a factor that will affect the position of equilibrium. And then another thing, concentration. By increasing concentration, obviously it will favor products, depending on whether you are increasing the side of the products or you're increasing the side of the reactants. But either way, we know that by increasing concentration of one substance in an equation, it will favor either the products or it will favor the reactants. And then when it comes to pressure, pressure only affects gases. So it has nothing to do with liquids and solids. So in your equation, you need to check that all the elements or the compounds are in a gas phase. When they're in a gas phase, then you can use pressure as a factor that will affect the position of equilibrium. Other than that, aqueous solution, liquid and solid cannot be pressure. Pressure cannot affect the solids, the liquids, and the aqueous solution. It can only be gases. Please just take note of that. Okay, so guys, yes, we do have these factors, but we need to understand that there must be a way to balance the system, because just because we're increasing temperature doesn't necessarily mean that the system will be disturbed and that's it. Just because we're increasing concentration, it doesn't mean that the system is disturbed and then we are getting nowhere. Same as pressure. That is why then we have what we call the Chateliers principle. So you are going to be asked in a lot of questions, especially on paper 2, on the application of Chateliers principle. What is Chateliers principle? So basically, in simple terms, Chateliers principle has to do with what? Has to do with stress or disturbance. There must be some form of disturbance in a system. Okay, and then the Chateliers principle would say that if there is such a disturbance, the system is going to respond by cancelling out the effect of change, which is the disturbance. Okay, so it will favor a reaction that will reduce or increase the disturbance. So whatever that you are imposing on equilibrium, the system wants to do the opposite. Okay, so basically that is the Chateliers principle. Say for instance, let's talk about temperature. If you are increasing temperature, Number one, you are disturbing the position of equilibrium because you are increasing the temperature. So the system would want to decrease the temperature. Okay, so in a case of a temperature, we look at exothermic and endothermic reactions. Now, exothermic is responsible for an increase in temperature, and an endothermic is responsible for a decrease in temperature. So, but let's not be confused, guys. An increase in temperature favors endo because endo is absorbing that temperature. But exo, on the other hand, an increase in temperature does not favor exo because exo would prefer to release energy rather than absorbing. Okay, so let's not confuse the endo and the exo. Okay, so now if I'm increasing temperature, I'm disturbing the system. That's the first thing that I notice. Number two, according to Chateliers, the system is going to respond by trying to cancel out the effect of the change. Which change? The increase in temperature. So what does it do? The system will favor the reaction that will decrease the temperature. Now between endo and exo, which one do you think will decrease the temperature? Endo, of course. Why? Because endo would rather absorb. It requires it's happy in the presence of heat to absorb that that temperature so that it can produce. You understand? So the system will favor the reaction that reduces temperature, which is endothermic. And then depending on whether it's forward or the reverse, then you will identify to say, okay, therefore a forward reaction is favored or the reverse reaction is favored. Basically that's it. And then coming to concentration, same thing happens. If I'm decreasing concentration, the system will want to increase the concentration. So according to Chateliers, the system will do what? Would respond by trying to cancel out the effect of change. Okay, which is a decrease in concentration. So the system wants to increase the concentration, so it will favor the reaction that will increase. In this case, what do you look at? You look at whether it's forward or the reverse reaction, depending on whatever is imposed on the system. Alright guys, we've come to the end of the first part of chemical equilibrium. I hope that you are going to find that information useful, and please guys, please remember to subscribe and remember to like my video.